Hello everyone and welcome back to Atman Unlimited. Tool setter time. Finally. We got a whole bunch of work in the shop, so I didn't have time to go back and actually play with the probes yet. So in our last video, we showed the installation of the probes and all of the hardware that goes into wiring them in and hooking them up and all the electrics. So in this video, we are going to concentrate on how to set up and do the initial calibration of a TS27 tool setter. So the first step that we're going to do is we're going to rough level the probe, okay? Then after that, we're going to use a test indicator to then dial in the top surface of the probe, and you want to get that top surface of the probe as parallel as possible. You want it as flat as you can get it, so you get good accuracy tool setting. It's also, the reason why it's so important is because the surface on the face of the probe is also perfectly perpendicular to the edges, so you want your tools to touch that edge nice and perpendicular and flush with the edge. So that's why we're going to spend so much time making sure this thing's flat. After we get it mechanically adjusted and flat and true, then we're going to come in and we are going to sweep it and find its mechanical center, so we know where the dead center mechanically is. And then we're also just going to test it and find out where it is electrically, okay? Because, you know, you have to deflect the switch a little bit to get it to trigger, so the electrical center may not be in the exact same position as the mechanical center. Once we find the center of the probe, then we'll come in and we'll find the height of the probe. So we need to know how high the probe is off the table, okay? Once we get all that done, then we'll put a dowel pin in a collet and true it up, make sure that it's got as low a runout as you can get, and then we'll come in and we'll test probe, and we'll test probe, and then we'll figure out what our fudge factors need to be. Last in this video, we will run the default Fidel tool setting algorithm that sets the height of the tools. I'm not going to set diameter yet. I'm going to make another video on how to set diameter, because on the Fidels you actually have to write a little bit of a program to do the diametrical measurements, and we'll talk in depth on why we're doing what we're doing, okay? But this video will cover all the setup of the probe, and then we'll show the measurement of a tool length. So let's get started. First, let's take a look at the tools we're going to use. So we have a thin wrench that we're going to use to tighten the stub that comes out of the probe, and then that stub also has a weak link in it, so when you have your oops moment and you break this thing off, the breakaway hopefully breaks before you actually break the contact on the probe. So here's the stub with the breakaway, and you can see the little undercut in there. That's the weak link. Now above that is kind of a leash. So when you break the probe off, or the stylus off the probe, it's nice that you don't lose it, because most of the time if the breakaway snaps, the stylus is still okay. But if you lose it in the machine, it can get jammed up in something, or you have to buy another stylus. So that's what that leash is for. Then we have two set screws. The small set screws are to hold the coupling element onto the breakaway and then also to the stylus. And then you have a little tiny cap screw that screws in the bottom for the leash. Then to top it all off, you've got the actual stylus itself, and then you have two Allen wrenches that you're going to need. I think I actually ended up needing 3 Allen wrenches. 2.5 millimeter, 3 millimeter, and then a 4 millimeter, if I recall. So these are the tools that we're going to use to set and adjust and tighten the stylus on the tool setter. So step 1 is to screw in the breakaway link, and you want to have that little leash underneath it so that it'll be attached to the probe. And then you need to use that little tiny thin wrench. There's a set of wrench flats on there that you can see. And you don't need to torque these real hard. Do not over torque these. So what I'm doing is I'm kind of holding the probe steady with one finger and then just giving it a little oomph with the other finger, and then bending up the leash so that it's in place. Next we'll install the coupler that's going to connect the stylus to the breakaway. Sorry, my thumb's in the way. These are small parts. So there's the connecting piece, and these are where the two small set screws come in. Then we are going to install the stylus in the top and then snug its set screw. And again, these don't have to be Gorilla tight. You know, just snug so that they're not going to vibrate loose, because remember, this is mounted to the table, and if you're doing some heavy milling, you can see a lot of vibration. Last, we're going to put the cap screw on the bottom through the other side of the leash, and then we'll tighten that up after we do the rough adjustment. Now we're going to do a rough adjustment on the probe. We're going to take a test indicator just on a stand that's on the table, and we're going to sweep it across the top of the probe. And then we are going to loosen the set screw and rotate the probe on the breakaway a little tiny bit. And you want to try to get this as flat as you can. So this is your initial adjustment. Now I ended up getting pretty lucky, and I was able to nail it within like 3 thou of level, which was pretty good in one move. So I got lucky. So then once you rough set the probe, you can tighten down the set screws that hold the stylus in, and then the set screw that holds onto the breakaway. And then last, we'll come back and we will tighten the bottom cap screw, and then the installation of the stylus will be complete. Then we'll move on to fine adjustments. One last check just to make sure when I was tightening it I didn't whack it way out, but we're pretty good. Now we're going to do the fine adjust, and the way that we're going to do the fine adjust is we're going to use the same test indicator, but now instead of having it just sitting on the table, I attached it to the Z column, so then we can jog the table underneath the test indicator, and you can see the values on the screen there in the indicator. Sorry it's a little bit blurry. This is with the original GoPro, but you can kind of get the idea. Now on the body of the probe there's actually 3 sets of adjustment screws, so you can adjust the flatness or angle of this probe in all 3 axes. So the first axis is to roll it in the Y plane, and to do that you use these 2 set screws on the left hand side. One tightening one will lift the base plate, and loosening it and tightening the other one will pull the base plate down. So that's how you can adjust the angle, and that's the first angle that we're going to adjust. You want to start at the bottom and work your way up progressively. So we are jogging X, and then we are going to rotate it in the Y plane to satisfy X flatness. So now I need to tilt the probe tip down a little bit, so I'm going to tighten the back set screw, and that's going to lift the back end of the probe up a little tiny bit, and you'll see that it has an effect. Now this is a little bit tricky because you can't control the point of rotation while you do this, so you got to kind of keep sweeping back and forth and nudge a little more, and then nudge a little more, and nudge a little more. So there's a little bit of back and forth going on here to get this thing dialed in. And it's not overly sensitive, but it's pretty sensitive. And you want to try to get this, below 1/10, if possible. Now when all your adjustments are done, what you want to do is you want to tighten both of these set screws, the set screw that's pushing down and the set screw that's pushing up. And when you have both of them tightened, it'll lock it in place. So you have to, once you get it adjusted in the spot that you want, then when you tighten the other set screw, you're going to upset it a little bit. So then you play a little bit of a back and forth fine tuning game just to get these both tweaked down so they don't move. So you can see here now we've got this thing dialed in. This is a 5/10 indicator, but you can see the needle is not moving at all. There's a little tiny bit of offset in my indicator between pushing and pulling. There's about 2/10 of offset in there, but when you're sweeping it stays stable. So now that we did the first adjustment, we're going to move on to the second adjustment, which is to adjust the rotation in the X plane. So that means we're going to jog Y back and forth. And now we move on to these two set screws in the top. Now you have to be very careful with these two set screws that you don't over tighten them. Loosen one first before you tighten the other one. So, and again, there's a little bit of back and forth here, and what this is going to do, it's going to roll the probe, so then that will give you your Y flatness. And again, you can't control the axis of rotation, so there's a little bit of back and forth here again too. Now, one thing I did not show in this video that I'd like to add is if you are using a stylus that is a cube rather than a cylinder, there is a third adjustment that you have to make. Now there's two additional set screws towards the bottom that will rotate the whole body of the probe on the base. Okay, and then that is used to square up the cube so that it runs, parallel and perpendicular in X and Y, depending on which side you're looking at. So that is important if you're using a cubic type stylus. When you're using the cylinder stylus, of course that adjustment doesn't matter, which is why I don't show it, but there's two additional set screws. So then after you complete the adjustment in the X roll, then you want to go back and adjust the roll of it back in X again, because I noticed there's a little bit of interaction between adjusting one and then the other. So I kind of just went back and tweaked each one a little bit. I only had to go back twice, and then it was pretty darn good. You couldn't even see the dial indicator move. So I'm pretty happy with that. After this, we can go on to the next step of testing and adjustments. So now the next measurement that I want to make is I want to know the distance between the top face of the tool setter stylus and the bottom of the table. Recall in my tool setting videos that I reference the surface of the table as my 0 for all of my tools. So to keep things consistent in the machine, in case I want to manually measure something, I'm going to use the same datum as well. So ideally you'd use gauge blocks. This is just a ground vice jaw, and it's within 2/10, so I know exactly the height of that. So it's my pseudo gauge block. So I'm just using my test indicator and jogging around to measure the top of the probe. And then this information needs to be typed into a work offset. So we're going to find both the top surface of the probe and then the dead center of the cylinder in X and Y. And those three numbers will become a work offset that will be later used during the tool measurement cycle. To find the center of the stylus, I just used the dial indicator again and swept in the diameter of the probe. Now if you have a cubic stylus that's a cube, you'll have to measure each side of it to try to find the center of it. Now after we complete finding the mechanical center and the mechanical height, then I went on and put a dowel pin or a gauge pin in a collet holder, and then I was able to find the electrical center of the probe manually by manually probing each side. You can write a routine that will do this automatically, but for now I just did it manually to show for the video and for my own curiosity. And the probe is very sensitive. It will trigger, within a 10,000th of an inch. After you have all the adjustments made and your work offset configured, now we can actually run the Fidel tool setting utilities. So this is the same utility that you would use to set the tools by hand, but now we're going to do it using the probe. So we're going to enter a starting tool number. We're just going to run one tool. And then we're going to tell it to probe, and you need to tell it to probe either the left or the right mount. Then it'll ask you what your work offset is. I used work offset 48. Then it will ask you if you want to apply additional Z offset. I said no. Then you enter in your nominal tool diameter just like you normally would. And then you tell it to locate the length, and it will ask you, is it a right hand cutter or a left hand cutter? That controls which way the spindle turns. Now it's going to begin the tool length measurement routine, and it's going to feed the machine down at 50 inches per minute until it detects a probe touch. Then when it detects a touch, it's going to back off, and then it's going to feed down at 1 inch per minute. Then it'll touch, and it'll back off, and it'll feed down at 0.1 inches per minute. And that's how it measures the length of a tool. And it changes the speed of the RPM. It speeds up the RPM of the tool for the final touch so that it will detect the cutter. We now have a fully functional working tool setter. And I'm very excited for this because it is going to save a boatload of time. Now when I set tools, I no longer have to manually measure all the tool lengths. I can throw the tools in the carousel. Okay, gently place the tools in the carousel, and then we can run the tool setting algorithms in the machine controller, and the machine will automatically pick up each tool, touch off, measure its length, touch off, measure its diameter, and then we should have nice, accurate cuts the first time, hopefully every time. In addition to that, the other option that this opens you up for is that you can do tool breakage detection. So for instance, if you're drilling a whole bunch of small holes, maybe like a 440 tapped hole, and then you have to come in and tap those holes, you can drill all the holes and then measure the length of the drill bit again and see if it matches the length it's supposed to be. And if it comes up short, well, the drill bit broke. So if the drill bit broke, you probably want to stop the program and not, try to drive your tap into material that's not drilled because the bit broke, right? So that is an awesome feature if you're doing, lights out running. The tool breakage detection can pay off huge. Okay, so what's next for this? What I found is that the macros in the Fidel machine are a little bit clunky for my personal workflow. I like to put all my tools in the machine. I put all my tools in the tool holders. I put all the tool holders in the machine, and then I want to measure all the tools. Well, the way that the Fidel macros are set up, we measure one tool at a time. And you got to stand there. You measure a tool, you type in the information for the next tool, and you stand there. And then you type in the next information for the next tool, and you stand there. So I'm going to write a macro that will allow you to enter in the information for all the tools, and then once you got all that typed in, you just hit go, and it will automatically go grab each tool and measure them all at once. So that way you don't have to stand there, typing in and then waiting for the machine and typing in and waiting for the machine. So there'll be a video coming up on that, and then I might offer that macro for sale or for use for other people as well. So cool stuff coming. And then next, we're going to tackle the spindle probe. So we have to do a very similar setup with the spindle probe. So you'll see videos on that coming up as well. So thanks for watching. Thank you for everybody's support, all our patrons, and everybody that has donated stuff to the shop. It is greatly appreciated. It's really making for some good content, and it's really helping me out. So I thank you very much, and thanks for watching. We'll see you on the next one.